Hello, AP Stats, Mr. Eicher here, coming at you with another mock exam. When are they ever going to stop? Oh boy, mock exam after mock exam. Mock 5. Mock 5 actually is a thing, right? Mock 4, Mock 5. Mock exam number 5, question number 1, the longer question. Hope you're timing yourself. Hope you're processing how you're going to do the upload process on the exam. Hope you've done that practice demo. That was an assignment before this exam. So let's check this out. Definitely want to read carefully when you're doing these kind of things. Notice it says a sample of 50 ripe strawberries, not a random sample. That's pretty significant. That's not accidental. But we do have randomly divided into 2 groups of 25 strawberries each, so we have random assignment. The 25 bags in the control group, there's a little clue that we have an experiment. Random assignment, we have a control group. Preservative is added to the 25, a little freezer, and then the strawberries discoloration level, these are numbers, numerical data, quantitative data, with a low score indicating little discoloration, so they're still red, I take it. And then a 10 is bad, higher numbers they're severely discolored. So what we have here, box plots are provided, and you're asked to interpret the third quartile. Now you'll notice here, in case you're interested, I've given you the data. It's really more for me if I want to redo these graphs sometime in the future. But there's the actual data, which you don't really have on the exam. Interpret the third quartile. The third quartile for the control group is this number. So you're interpreting 8. There's 2 ways to do it. You could say 75% of the strawberries in the control group, right? 25%, 25%. 25%, 25%. So that would be 75% of strawberries in the control group had discoloration ratings of 8 or less. You could also say less than 8, either one. Or you could say 25%. You can go this way. You could say about 25% of strawberries in the control group had discoloration ratings of 8 or more. So that's an interpretation of the third quartile. Now I'm guessing on the AP exam, they probably ask more questions like B and C, because in part A, that's kind of like if you have good notes, then you could just look at your notes. How do you interpret third quartile? Not that you want to waste time, a lot of time doing that. But I wanted to throw that in because that could be useful when you're asked to do some statistical thinking, comparing these distributions. Maybe comparing the quartiles would be helpful. Compare the discoloration ratings for the 2 groups. So to get full credit, you'd want to use comparative language, which one's greater, which one's less when it comes to the center and the spread. And definitely make sure you use context. You want to mention the label here, discoloration rating, and you want to mention the control and the treatment. And then lastly, since we have quantitative data, box plots, we're going to use SOCs. So an example would be the discoloration rating, check, context, for strawberries in the treatment group, more context, had a lower, comparative language, lower center, so the treatment group lower center, that's lower than this one, than the control group. The treatment group had slightly more variability, that's the spread. Treatment group had slightly more variability with slightly higher range, so this range is a little bit bigger, and then this interquartile range, this distance here is slightly bigger than the interquartile range for the control. Both shapes appear roughly symmetric. Now, if you wanted to say, like, this one maybe, I don't know, like maybe right skewed, and then this one might be left skewed slightly, I would only say slightly. It's not very obvious. And like we've said before, peaks and gaps are difficult to tell. Gaps are difficult to tell with box plots. So you don't want to mention gaps. You don't want to mention peaks with box plots. But you definitely should mention that there are no outliers. If there was an outlier, it would be, you know, a little mark on the side there would indicate an outlier. So I think we got everything. We got the shape, outlier, center, spread. You can kind of guess the shape, left skewed or right skewed. But again, it's difficult with box plots to know for sure. And I'll mention again, roughly symmetric is a better term to use with box plots. you don't want to say roughly or approximately normal. If you said that, then your E that you may have gotten is going to go down to a P. You're going to go down one level if you use that language. Since we can't tell peaks and gaps, we can't tell if a box plot shows data that's has a unimodal peak. It might have 2 or 3 peaks for all we know. Question C, based on the graphical display, comment on the effectiveness of the preservative in lowering the amount of discoloration in strawberries. I said, the treatment appears to be effective, other than the maximum, which is equal for both groups. You can see up there 10 and 10. Every number in the 5-number summary in the treatment group is lower than its corresponding number in the control group. In addition, the 3rd quartile of discoloration rating in the treatment group is lower than the median of the control group. So what I'm pointing out there, if you can tell with all this writing here, maybe I'll get rid of some of these. There we go. So what I'm saying is, hey, the treatment, like lower numbers are better. This 3rd quartile is lower than the median for this control. So that's 75% are lower than these top 50%. So that could be pretty good evidence comparing quartiles and medians and things like that. You could also say, you know, this median is lower than the 1st quartile. So there's a much higher percentage that are lower than this 1st quartile in the control. So it does appear to be effective. Next question, the standard deviation of ratings for the control group is that number. Explain how this value summarizes variability. That's basically interpret standard deviation. So I said in the control group, the typical discoloration rating for a strawberry varied 2.141 rating units, whatever the units are, away from the mean. I think it's pretty important to mention that it's variability away from the mean. Standard deviation measures the variability away from the mean. The range doesn't do that, the IQR doesn't do that, but the standard deviation does do that. That's how it summarizes the variability. It's the variability away from the mean. And again, make sure you have context is really important there. Next, you're provided a confidence interval. So like I've said before, it will be unlikely that you'll have to do the calculations yourself, which some students are really appreciative of. But part I says, verify the conditions. So first, the strawberries are randomly assigned to treatment groups. It was not a random sample. If you said random sample, you're going to lose points. Or if you just say random check, you're going to lose points. It's random assignment. And I've included, just for the benefit of everyone out there, why is that important? It's important because it allows us to make cause and effect inferences. We want to know, is the treatment on the strawberry actually causing the color to stay good on the strawberry? Or is it something else? And like I said here, we can't generalize to the population because we don't have a random sample. That wasn't required necessarily, but you could be asked a question, why is it important that we randomly assign the treatments? And then the next condition we have, although each group size, or sample in a sense, but each group, since it's an experiment, each group size is small, less than 30. The box plot showed, the box plots provided show no strong skew or outliers, so the normal condition is met. That's another condition. You don't want to just say no strong skew, check. You do want to reference that, hey, this has to apply to both. In the box plots that you gave me, neither one of them has strong skew or outliers. And then lastly, we will not check the 10% condition since it's an experiment. So typically with experiments, if it's an experiment, it's safe to avoid all talk of independence. Now, if it's an observational study, a random sample, you should check the 10% condition. But I'd recommend not talking about independence for safety's sake. And then part 2, based on the confidence interval, comment on whether there would be a difference in the population mean discoloration ratings for treated and untreated strawberries. And as you can tell, the interval is 0.16 to 2.72. I said since the entire interval is positive, there's convincing evidence that there's a difference. I like the evidence language. It's much better than saying that there is a difference. We have evidence of a difference. We could have made type 1, type 2 error. And what you probably mentioned was, hey, 0 isn't in the interval, so that gives us evidence. You could go either way. So this implies that we'd have a small p-value if we have convincing evidence like this. I included here, this question was based on a question from 2007, question number 1. So I included here the sophisticated College Board scoring rubric in case you wanted to check that out. We'll just move on to the last part that I've designed for you because I love you. Researchers are considering a follow-up study using a randomized block design. I wanted to review randomized block design. Give an appropriate blocking variable and justify your choice. Describe what randomization would look like in this type of design. So first things first, a possible blocking variable is, here's one example, type of strawberry. Perhaps different types of strawberries are affected by freezing than other types of strawberries. Different types of strawberries may also have different discoloration rates. Some types may last longer than others. Blocking by strawberry type will help us reduce the added variability in discoloration that may occur if we had all the types mixed together in each treatment group. So blocking is a form of control, and we're controlling for things, these blocking variables. We're trying to control for things that we recognize may create added variability and make it harder to detect that there's actually a difference. So in a sense, blocking can help increase the power of your significance test. You want to increase the power so you're more likely to see that this treatment does have an effect and it helps the strawberry stay red longer. So that was the first part. And justifying my choice is saying basically this statement: why did I pick type of strawberry? Now, I guess you could have chosen another one. Maybe you could choose the weight of the strawberry. Maybe strawberries of different weights will discolor at different rates. So you'd have to kind of, a little imaginary, creative thinking, I should say. But then I also wanted to review what randomization looks like in a block design. So that's what I do down here. Suppose there are 3 types of strawberries, A, B, and C. I don't really know what types of strawberries there are, but let's just imagine there's 3 main types of strawberries. We have 50 each. We take 50 type A strawberry, so 50 type A. Draw you a little picture. We're going to randomly assign half to the treatment and half to the control with some random process. Maybe have a 50 slips in a hat, 25 say treatment, 25 say control, and as you go along to each strawberry, pick a slip out after you've mixed them, pick a slip out and assign it to that strawberry. Then we're going to put them in the freezer. We'll perform the experiment, so we're going to do the freeze, and then we're going to check and compare the ratings after they're frozen. That's one block. This right here is one block. Now we have another block. Let's take 50 of B type of strawberry. We'll randomly assign them to half to the treatment, half to the control, and then we do the freeze and comparing process. And then likewise, finally with C. One of the main points that you want to mention is when the random assignment happens, it happens after you've put them into their different blocks. Then you randomly assign them half and half, or however many treatments you might have. So I wanted to review randomized block design. That's something that you might be asked to explain how to randomize, when to randomize, and what blocking variable you might choose. Probably the thing that students miss most about block designs. In this question, I was very specific about justifying your choice and tell me a blocking variable, but sometimes in past exams, they haven't asked students for that, and they want you to mention that, even though they don't say explicitly. And frankly, even when they say justify your choice of blocks, students still kind of ignore that. And that happened on the midterm. I had a question about windows. It was kind of a picture like this, and you had these different window boxes, and you had to justify your choice of blocks, where to put an A type, where to put a B type window. And in that question, it said justify your choice of blocks, and many students didn't do that. So I'd encourage you, hopefully the AP exam would be kind to you and tell you what they're expecting, justify your choice of block. But I'm here to tell you if they don't, it's still good to include that possible blocking variable and why you're choosing that blocking variable. Don't just assume that people understand, oh yeah, type of strawberry, that's an excellent idea. You need to justify your choice. Well, I appreciate you watching this video. I hope that it was helpful. Give me a thumbs up if you liked it. And please message me with any questions you might have so I can help you out and help you get ready for the big test day coming up. Have a great one.